Okay, up next we have Bryan Fields, who's going to talk to us about high-speed IP radio. I think you got your set on, so. You ready, Bryan?
Yeah. Hold on.
Okay,
Okay.
Bryan.
I'm live. Okay. I'm more, wow, there's a lot of people. Oh my God, I didn't realize this until I got up. Anyways, I'm Bryan Fields, W9CR. It's a newer call for me in the last couple of years. So just getting some stuff set up there. I don't have a demo, but I have some props, and props are always a good thing to have. Anyways, I'm originally from Southside Chicago, Northwest Indiana area. Live down in Florida right now. Have no plans to go back. I actually had to bring my winter jacket up here. I thought it was going to be cold and raining all weekend. But hopefully it won't rain. My background is really in carrier IP networks, microwave design, and I do a lot of stuff with IETF. It's an Internet Engineering Task Force. Really have been in all aspects of carrier IP networks since I got started in networking back in about 1999. Currently, right now, I'm a senior consulting engineer in the transport division at Alcatel-Lucent, or Nokia. If you know about that, it's really funny. I'm also on, well, let me ask this. Anybody know what AmperNet is?
Yeah.
Oh my God, this is the first time I've actually seen hands go up when I give this presentation. I'm on a technical advisory committee member, which means I have no real authority to do anything, and we get together and do planning once in a while. So what I'm talking about here is similar to what they did. Now I'll differentiate that a little bit, but it's basically IP networking, basically what I'm proposing with HamWAN is essentially the same thing as running your own internet. It is running your own internet. And anything that runs currently over the internet can work with this technology. It's IP end-to-end, web browsers, Skype, whatever works across it. Currently though, every device needs a unique IP address. Just so happens that ham radio has this wonderful resource in ARDC, which is an amateur radio digital communications. It's a nonprofit, in an entire /8, or about 16 million IP addresses. And that's very critical right now, because IP addresses are scarce and expensive. We actually own them outright as ARDC, which is fairly amazing. ARDC and AmperNet are the same thing. So we have to have that, and we have to have a way so that all networks can know about this. We deal with that with different routing protocols that tell us where different IPs live on the network. This is actually different than the broadband HamNet, or what they just presented. That's more of a itinerant type solution. You bring a whole bunch of nodes in, you set it up, they all link up, and you can pass a little bit of data across them. And you start getting into the inefficiencies when you have multiple nodes connected to multiple nodes and so forth and repeating. This is a fixed architecture, meaning that it's put in place. You set it up like you'd set up a repeater station or a fixed packet node or something. It's not a strictly emergency communications thing. It works during non-emergency times as well. It's very ideal actually for using the broadband HamNet to hang off of one of these nodes to get kind of access into broadband HamNet and bridge gaps that are in their coverage area. So some of the practical applications. I'm going to have an asterisk here, and I won't get too far into this because normally when I give this presentation, it's about an hour long. But essentially, we can do general internet access. We can do all these repeater linking applications that are out there. If you know about the All-Star link or IRLP or even Echo link. I have an All-Star node. I think most people are going All-Star now over IRLP. It happens to be open source versus controlled proprietary. I really like stuff that's open source. The NXDN V25, it's all multicast IP, which is really ideal for this. The web SDR, you get interface to this where you can hang one of these off of a wireless node and give it access, and even use it as a remote monitoring station if you want. These are just an idea of some of the applications you can use. You can use anything literally that runs over the internet over this, because it is the internet. These guys are actually cool. This PhotoCam webcam, this is in the European ham WAN. These guys have about 4,000 nodes, and they're actually doing backhaul for high-resolution digital cameras. This is, I don't know what city this is, somewhere in Poland, and it's under the cloud. It's very, very cool. Here's what some other people are doing around here. This is the ham WAN group out of Seattle. I don't know if you've heard of them. There's two major groups here. Some stuff I'm doing down in Tampa, St. Petersburg, ham WAN, Seattle, also Memphis ham WAN. I have Bryan K0RET. Here from them, they have a banner over at the Capra booth. We're going to be doing some questions and answers over there if you want to come by and pick our brains. And the other guys are the European Hamnet, and they have a website, HamNetDB. They have about 4,000 users. Can you imagine that? 4,000 users on the microwave bands that are licensed amateur radio operators spread across Europe. It is amazing. Currently, right now, they're in the process of getting their own gateway. Right now, all their stuff that goes to the internet gets tunneled all the way back to the US. It's a fairly inelegant way of doing it. This is their deployment. And this is, with the exception of the UK, pretty much everywhere in Central Europe has it. The gentlemen that have deployed it are based out of, Germany, so they're pretty well represented. France, not so much. So, I guess the question I always get asked is, why do we need this? And the reason why we need this is we need a backup of our commercial internet services. It doesn't do us any good if we can say we have a linked repeater network, and the second your cable modem goes out, all the links go down. That's unacceptable for ham radio. And simply doing conventional repeater linking with simplex radios and things like that, it does not scale. IP is proven to scale. And the only evidence for that is every single provider, whether it's a public service agency or somebody selling something to them, has chosen IP as their transport. Everything is going that way, if not already there. So we're slightly behind on this. Problem is, most of our microwave bands, they're shared with Part 15. And as the broadband mesh guys alluded to, as soon as everybody comes in on 2.4 gig, it's not going to work. This uses some of our other microwave bands that are close to Part 15, but don't overlap with Part 15 users. Not to say that there isn't a good use of Part 15 bands or the ham bands that overlap with that. We certainly have some good use there. It's just during any sort of emergency, all these itinerant things come together and you can have real interference problems. I've had that as of last week even. So, anyways, the problem is these Part 15 operators, they have trashed the bands. And I want to point out a couple of things here. They're really looking right now saying, hey, these hams have space. They have a lot of microwave bands. We're not doing anything with them. We should take them. There's a couple things. We have one exclusive 50 megahertz slice of band, 5850 to 5925. I know that's 75, but it's only exclusive to truly 50. That's designated as unlicensed national something infrastructure. It's called a UNI-band 4. It's been designated that internationally. The FCC has not done anything about that. It's still exclusive to us in terms of ham radio, but they've got their eye on it. 10 gigahertz, the 10 gigahertz band. Mimosa Networks has a petition out right now with the FCC to take away all but 20 megahertz of it and give it over to wireless ISPs with an EIRP of 55 dBW. That's 85 dBm EIRP. I did the math here, 316 kilowatts EIRP. How's that going to work? I commented on that. And what's ironic is some of the people that commented in proposing, in favor of it, have actually been fined by the FCC before for violations. The one band I really like, which is 3.3 to 3.5, the 9-centimeter band, that's next. There's a couple small allocations, but it still doesn't overlap with us. However, the UK hams have lost, I think, all but about 5 megahertz of that in the 23-centimeter band. So we need more activity there. Say, hey, there's people using it. I'm not going to go into all the legal issues. I'm going to say, as you all are aware, Part 97 puts a number of restrictions on what you can do and can't do with the bands and what kind of traffic you have. I think legally right now, if you have a station set up repeating, you're responsible for every single packet that goes across there. I'm not worried about that too much. I think it's better to build something and work with a potential violation that might crop up when the FCC comes calling than it is to not do it and say, well, it's a rule, I can't do anything about it. I'd rather make a good faith effort to comply with the rules and deal with what may happen. The FCC is fairly easy to work with in that regard. The big thing is, as far as I read the rules, you can't do encryption, which I think we all probably aware of. There's a couple of different problems this presents because you have encryption of internet traffic, you have encryption of the links. Definitely encryption of the links isn't there, but some traffic may go across that's encrypted. I'm not really filtering that. I don't know if you should or not. That's for you guys to decide. How do you actually identify your links? Well, easy. You can set one side of the link if you're owning it on both sides to your call sign, the SSID. It's a service set identifier. The other thing you can do is pings, things like that. The Hamland guys out of Seattle, hamland.org, they have a number of standards available for that. The big thing on this is only licensed amateur radio operators are part of this. I don't want to do something where it's allowing everybody general internet access. No, it has to be for hams only because we're using amateur radio only frequencies. So in terms of the equipment that we have, and I have some of the equipment up here, I'll go through that at the end. We have really two major vendors of product that we can buy from that are in our price range as hams. One is Microtik, and the other one's Ubiquity. Microtik's kind of cool. It's a Linux-based thing. They're based out of Latvia. Say what you will about software-based routers. I think they're horrible, but I work for a major router vendor, so they work really well for ham applications. We're not trying to do gigabits of traffic here, or in my case, terabits of traffic. Ubiquity, they kind of have their own two different OSs. One's better than the other. They're not particularly ham-friendly right now. They've actually gone through and shut down a lot of their stuff to be able to make it go into the 5.9 gig band. However, they do have some cool stuff for 3 gig, so there's different ways to look at it. The other one is DP2. They make some little micro PCI cards. So you use a little radio card, put it into a Ubiquity router, and now you have a ham radio. So this is typically what a deployment looks like at a base station. You have up here at the top, these are your sector antennas for access at 5.9, and then your backbone radios at 9 centimeters. And these are all high gain. We're using, on the backbone here, we're using what's called MIMO, which uses both horizontal and vertical polarization simultaneously. It actually uses interference between them to increase the amount of bandwidth that's available for data throughput. Won't get into the math behind that, but it's fascinating. This is typically what you have at a client site. We have one of these here, right here. This is the antenna, same thing there, and what's called a Microtik metal. So this is a 5.9 gigahertz radio, 29 dB antenna. We're talking under $200 to put this at your house or a client site connecting to one of the access points to one of the base stations. Typical install. This is actually Bart's old house from the Hamland guys out in Seattle. As far as our microwave bands, we have, essentially this is our 5.9 gigahertz band right here. You can see here's our entire band, but it overlaps with 5.4, 5.8, and the ISM band. So we really only have this slice right here that we can use that's guaranteed to be interference free. should be interference free. I've actually had some interference from operators putting their stuff there. That's easy to solve. The 3 gigahertz band. This is nice because we're not even anywhere near the commercial operators. There's a Part 90 license, which is now grandfathered, and there's Part 96, this is new as of 415. And this is the coverage of a Ubiquiti M3, and this is coverage of the DB Network's FN36 Pro. You can see we cover almost the top 125 megahertz of the band. So 3.4 to 3.5 gigahertz is entirely ours, and we do with it as we please. Basically, microwave is line of sight. So, you know, there's some problems here. It'll modulate down. And what we like to do for providing reliable internet access and reliable access on our links is model our links so that we have a good deal of fade margin. So this means shorter links. We might be able to get a link that's 40 miles, but it's not going to be reliable, not because of rain, but because of fading and distortion that happens when we have rain. So there's a couple of free calculators out there. I think everybody's probably heard of Radio Mobile at this point. That is kind of okay for doing path loss. It uses a different modeling program. It's more of an area coverage tool. You can do it by hand if you want. It's pretty easy with microwave. There's another one that I like to use. I have it for work. It's called Path Loss 5.0. It's kind of the standard of microwave radio propagation. The problem is it's about $7,000. But if you want me to model a link, send it to me. I'll model it for you until I start doing everybody's links. So in terms of network architecture and backbone, we have a couple major parts of the network. We have access points, our backbone links, which I've showed are 9 centimeters, and then routers. We like to have our access sites co-located with conventional digital repeaters, things like that. That way we can easily hand off an IP link to them and now put the repeater on the air or do it in EOC or somewhere like that. And again, it should be on battery backup. We run everything off of UPS 110 volts. It just makes it easier. So this is kind of what the network overview would look like. These are all your backbone sites all talking together. You can have clients hang off these. And then this is what the site actually looks like inside. So here's your site. You have an east and a west radio, and these are the 3.4 gigahertz radios. And then you have some 5.9 gigahertz access points. I know it says Microtech, and I got a picture of Canopy up there, but it's the only thing I can find. So, and then you have your end users talking to the access points and using a different radio path to get the traffic away from the site. This allows you to have less contention and do higher actual bandwidth and start getting into things like quality of service, doing reliable voice over IP without having to worry about interference from other users. And then finally, and probably the most important thing that sets us apart is we have a router down there. That router makes intelligent decisions based on where packets should go by running a routing protocol. So every single router on the network knows the condition of the network. And if this link right here fails, it automatically routes traffic onto the other link. And in most cases, you don't even know about it. You see an alarm or something, but that's about it. So, kind of already went through what routers are, routing protocols. I'm not going to go into that. If you want to talk routing protocols with me, please do so. Yep. Awesome. And the other problem we have had, and this is more of an issue for me down in Florida, is we don't have a lot of tall things to go on other than buildings. There's been a lot of consolidation of real estate, which means site acquisition, tower sites really aren't ideal because there's been a lot of consolidation in the tower industry. Has anybody had the misfortune of having a site get sold to American Tower or somebody like that? And hey, you hams, you can pay $2,500 and a $2,000 engineering study to put one antenna up there. That's not going to work for a nonprofit organization such as ours. Because we like to do links and move stuff around fairly regularly. I like buildings. Most of the time you can find buildings, you can get on them, they're easy to work with, and if you're a nonprofit organization, 501c3, they can deduct the fair market value of what they're giving you off their taxes. Most people like that. You've got to have a legal document. Got to have a legal document. You can't just go out somewhere on a handshake. We've literally lost equipment because of that. and we're dealing with equipment that we might have to put that's $1,000 at a site. I don't want to lose that. So I need some interest in this. We have a couple of groups in the area, in the country, excuse me, doing this. I'd like to get more people doing it in their locations and wherever they want to go, wherever's home for you. You don't necessarily have to be a networking person. It helps. What I found is the people that are into this, that are networking people, are really into it. I'm really into it. What's kind of cool is we can interlink entire states. I would love to do something personally that interlinks something outside of Tampa Bay. I'd love to go south. I'd love to go north. I mean, I have delusions of grandeur. The aspects of this from public service. We can do reliable multi-megabit data services. The problem with mesh, well, it's great for itinerant when everybody shows up and we have nothing existing. This we can deliver megabits of data and process it reliably. I'm using this to bring younger people into ham radio because there's some high school networking classes where they actually teach kids some of the Cisco certifications, but they're interested. And this is more like service provider networking, so it's not something they have access to. A couple of our groups, and this is going to be available, I think, on the website, download from Tapper. And feel free to use my slides too if you want to, if you need to present this. They're all licensed GNU, free document license. My group that I started, we're 501c3, Memphis Hamland, and we have Bryan from there. He's going to be at the booth today. Come by, talk to us, we'll have a banner up. 44net. These little guys will get you IP addresses. We have an email list set up for that. There's a procedure for that. If you have any questions, give me a call, give me an email. I'll try and help you in between travel for work and everything else. And then most importantly is HamWAN. These guys have really set the bar and set standards. We also have HamWAN and 44net on Freenode IRC. I'm Dark Helmet on there. Come by, say hi. It's a nick. That's how IRC is. And that's basically my presentation. I got a couple things that I was going to show here. This is what one of the typical sector antennas looks like. So this would go out and talk to client customers, which have these things on their house or other site. These are very small. They're unobtrusive, so they're not like putting up a huge DD420 repeater antenna or something like that. And they're cheap too. These are a couple $100.
Which band is that on?
That is a 5 gigahertz. That's a dual polarity 5 gigahertz antenna. We try to stay out of 2.4 because the ham band overlaps 100% with the ISM band. And I was just at a conference for work at McCormick Place last week. The guys brought in wire. Our corporate people didn't want wires at our booth, so everybody had a wireless mouse and keyboard to work the demos. I made an emergency, I counted over 350 access points just on my phone in 2.4. It didn't work at all. Had to run the micro center and an Uber back and forth through a $150 cab to go pick up wired keyboards. So that's why I want to stay out of that. I think we have a lot of bands that don't overlap, and for this infrastructure-based stuff where we have some time and can plan it out, we can do some amazing things there. So come by the booth, talk to me, send me an email. I really want to get some people interested in this. Thank you.